As we just saw, depending on what part of the equation is squared, whether the x part is squared or the y part is squared, we're going to end up with either a vertical parabola or a horizontal parabola. So as an example, notice that on this part, the x part of it is squared, so we have a vertical parabola. Whereas on this one, the y part of it is squared, so we have a horizontal parabola. The other thing is, depending on, if we look at the non-squared part, so this part here in this case, or this part that doesn't have the square in this case, if we look at either of those unsquared parts, the number in the front, this coefficient, if it's positive, then we're going to have an upward facing parabola. If this coefficient, if this number here, 4p represents a number, if this number is negative, then it's going to be a downward facing parabola. Whereas if this number is positive, it's going to face to the right, which is the positive side on the horizontal. If it's a negative number, then it's going to face the left on the negative side of our horizontal. Another way that we can draw a parabola is by starting with a line that we're going to call the directrix and a point that we're going to call the focus. So the parabola, we can say, is going to be based on points in between the focus and in between the directrix. So as an example, this point here is a point that's on the parabola, and it's between the focus and it's between the directrix. So this point P is between the focus F and this directrix here, where the Q is. If we were to get another point, let's say here on the parabola, we can say also that it's still between this point which is the focus, and this line which is the directrix. And if you notice that it's the same distance from the directrix, so this point is the same distance from the directrix as it is from the focus. We want to see, is that the same for all points on a parabola? So let's say we picked a point over here on the parabola. Notice that the distance between the point and the focus is the same distance between the point and the directrix. So that's going to happen for every single point that we have on a parabola. So one way that we can define a parabola or make a parabola is by getting all the points that are the same distance away from the directrix as it is away from the focus. So it's going to be the same distance or equidistant from each or to each. So we can see whether we have a vertical parabola or a horizontal parabola. We can see, basically, we can make a parabola by thinking about a point, which is a focus, and a line, which is called the directrix. And any point on this parabola is going to be the same distance from the focus as it is to the directrix. Also, once in a while this comes up, but when we talk about the focal width, we're talking about how wide is our parabola if we draw a line straight through the focus. So how far is it across when we go through the parabola? That's all the focal width is.